Okay, welcome everyone. This is the Working Group Device Management meeting for September 24th, 2025. The meeting, as usual, falls under the CNCF Code of Conduct, which basically means be excellent to each other. We have one item on the agenda today that is CAP planning, because the release cycle for 135 has started. Well, has started a while ago already, but now we have a release schedule announced by SIG Release. We can do the usual round of introduction. If anyone who's new to the meeting wants to introduce themselves, please raise your hand and you can say a few words what you're expecting from the meeting, ask questions. If not, then I'll get started with giving you an update of where we are with release planning for 135. Yep.
Hi, I'm trying to figure out how to raise my hand.
There's a reaction button somewhere in your suit.
Yeah, there we go.
Yeah. Okay, but go.
Sorry.
Yeah.
Should I
So,
go and
yes, please.
Oh, okay.
It's you.
Hi, my name is Antu, or the letter N, the number 2. It's easier to remember phonetically. Um, I have about 30 years of experience working in software. Currently, I'm the Vice President of Engineering and Distinguished Engineer for Edgevana. We're an Edge AI infra. And since 2010, I've been working in software-defined networking, then software-defined infrastructure at VMware, and Kubernetes on bare metal at Cray supercomputer. And then my last recent job was distinguished engineer for Marvell Semiconductor, the Octeon DPU series, and now Edgevana. My interest is using basically the ability to create a logical processing unit, which is more than just memory and CPU, monitoring, telemetry, but also thermal power, workload status, GPU consumption, VRAM, all that, and use that to feed into real-time telemetry to a cube scheduler or a plugin. So I thought this would be the appropriate forum to join.
Yeah, it could be. So
Yeah.
with dynamic resource allocation, we're trying to enable more advanced scheduling,
Yep.
adding more devices in a format that allows the scheduler to make better decisions than with device plugins, where basically really very little is known about devices. What you described sounds like a fairly complex use case, so it might not actually do everything that you want, but we are adding more things to DRA to handle such advanced use case. So it might be the right forum.
Yeah.
Thanks for
I
the
I
intro.
talk
Yeah.
Oh, sorry, really quickly. I used to work on Nephew with John Balamaric.
Yeah.
So when I talked to him earlier last week, he mentioned that I should join this group and start following the work. The use case I described is more advanced. Like he said, also not quite exact match, but is a good starting point to device management working group. So looking
Okay.
forward.
Yep. Well, I look forward to plenty of interesting discussions.
Yep. Thank you.
I hope you have found our introductory material already. So we do have quite a bit of documentation now on the Kubernetes website, how to set up the cluster, how to deploy the example driver, running through some simple setup or claiming resources. I think that is all now documented. And then the example driver itself shows how to write a DRA driver. So, and if there's anything that you want to clarify, any questions, you can do it either in this meeting here. We have the same meeting also in a US Europe friendly time zone on the next Tuesday, or you can go to Slack. So all of that works, whatever suits you.
My cluster, by the way, is not just a typical GPU, cloud GPU, but also edge. And we manage both edge and cloud GPU. So it's going to be interesting. For example, DCGM is specifically for NVIDIA Cloud GPU, the A100, H100B series. And then we use Jetson as well as the L4 and L40. So for the Jetson, there's Tegra Stat and there's a JTOP that give us power and thermal telemetry. So I'm writing a CRD, well, not a CRD, a controller to capture that and feed that to the Cube scheduler in real time, just to see what happens. If that gets somewhere and if my company agrees, I can, we can feed it back if it's of interest.
Yeah. Okay. Nitish, you also have your hand up. I hope I pronounced the name right. I was purely guessing.
Yeah, hi. Yeah, this is Nitish. Yeah, thanks, Patrick. Yeah, this is my first time here. I work for AMD. So, yeah, this is something that we are interested in. I've been looking at DRA for quite some time now, gone through all the documentation, experimented with the drivers for our hardware, and it looks really interesting. Yeah, I've been asking some questions in Slack, and yeah, thanks, Patrick. I think you have been answering them. So yeah, looking to work with this group, yeah, to support our use cases going forward. I think I'll be joining the Tuesday calls from now on. This is quite late for me. I work in California time, but yeah, happy to be here.
Yeah. Oh, well, you're welcome. Well, we started this meeting here because we had contributors from Asia, and it was just impossible for them to attend the other meeting. We do have different audience or different participants here. I'm located in Europe, Germany, so I can do both. This is morning time for me. The other one is afternoon. But we don't have John, for example, here. He's in the US.
Nope. I'm in California also, but I'm a night owl, so.
Yeah, well, I'm here. I'm basically I usually join the meeting here, and it's participant is quite a bit lighter than on Tuesdays, but we had some good discussions around consumable capacity, for example, because the author of that is from, I think, Japan, if I remember correctly. She's not here today. Yeah, let me use that to seg into the planning discussion for 135. So the first link is a Slack link. I can't open that in my browser here, but the second one is a table that we keep updated. See whether I can make it a bit bigger. So this is roughly the caps that we currently have in flight. It doesn't actually list the core DRA anymore because we graduated that to GA in 134. Now all the remaining work is some cleanup, but doesn't affect the feature itself. It's about API groups enabling. It can be disabled still in 134 for technical or procedural reasons, but it's on by default. So these are the caps that really need, or that we are still actively working on. Bit sorted by priority. Extended resource requests is a feature that smooths the path towards enabling DRA in a cluster where people traditionally use device plugins, because it makes extended resource requests work after the cluster has switched from device plugins to DRA, assuming that there is a driver for the same hardware. And that's obviously important because we don't require that people rewrite, or we don't want to require that people switch from the extended resource API to resource claims. And this cap enables that. So it's a high priority because it affects how people actually roll out DRA in real world. It was alpha in 134. We want to aggressively promote it to on a tight schedule, promote it to beta in this cycle because it is so important. Usually features stay in alpha for a bit longer. We'll see that when we go down the list. Resource claim status, that has been in beta for 2 cycles. We think it's ready for stable. No API changes needed. Has some drivers that use it. So that seems like a fairly obvious candidate for graduation. Same with namespace control admin access. That's a smaller thing too. So that seems likely to be done. Doesn't need much work too. That's a good thing. Device taints and tolerations. That's a feature that I've been working on. It got initially introduced in 134, about 133. Then I didn't do much with it since then. I skipped basically one release because I was busy with a GA graduation. And now that I'm coming back to it, there have been additional requests for changes, new ideas, and that means I'm changing the API quite a bit, which almost certainly rules out going to beta with a new API that hasn't been in a release yet. So another alpha is likely to be the outcome in 135. But we do have ideas that for how to use it. It seems useful, so we made it a priority to continue with it. Now with partitionable devices, we get to the point where we want to do something, but we need to figure out whether we have the resources in terms of reviewer bandwidth. It is changing the API again. So same situation as with device taints. It has been in alpha, actually the same for the same duration, but we'll probably just do an API update and keep it in alpha. It's a bit of a pity because one of the original promises of DRA was to have the ability to dynamically decide at scheduling time how to split up a device that supports partitioning, and we still haven't delivered on that, but we'll get there. Resource health status, it's listed as beta, but we need to check. So everything below resource health status is depending on, is a bit questionable whether we get to it. Yeah, question, Antu?
Yes. The MIG, the partitionable devices. Pardon the newbie question, but is NVIDIA involved in that effort?
Yes, they originally came up with the idea and the design. The current developer is Morten. He is working for Google, but Google also has use cases around it, and he has more time to work on it. So yeah, but yeah, Kevin Clues from NVIDIA is definitely involved, keeping an eye on it, and once we have it sufficiently stable, the NVIDIA driver will use it for MIG.
And the other newbie question I have is at scheduling time, that is runtime, right? We're not talking static scheduling or dynamic scheduling, as in feedback loop.
So the whole approach with DRA is that the devices get described with sufficient information for the scheduler to make a decision. For partitionable devices, that means that in a resource slice, which is more or less static, it's not supposed to change much.
Okay.
The DRA driver describes that it has two, let's call it partitionable, or two logical devices, and they are they are mutually exclusive. The simple solution is two devices mutually exclusive because they represent different configurations of the same underlying hardware.
Okay. Got it.
And the scheduler then knows that if it chooses one device, it basically locks the hardware in one mode,
Yep.
and it can't use the other device until eventually the pod that uses the first partition has completed, and the device, that partition of the device is no longer in use. Then it can go back to choosing between two devices or more freely, and then perhaps ask the node to reconfigure the device in a different mode.
Okay. Got it. Thank you.
Nitish?
Hey, Patrick. Yeah. So I had a pointed question about this partitionable devices, and I went to the KEP. I understand that I think the current design does introduce some sort of relationship between the partition devices and the full devices with the help of the shared counters. Um, I had a use case where um, I would have to define some sort of relationship between full devices too, as in within a slice, if you have multiple devices advertised, then how one device is partitioned basically controls how other devices are partitioned, sort of, putting a relationship between these devices. Is there any KEP or anything that addresses this sort of relationship between devices today?
No, I don't
Yeah.
think so. I saw your
Okay.
question on Slack.
Mm.
Not sure whether I answered. What you describe sounds like a constraint that needs to be applied to a subset of devices within a resource slice, and it needs to be a constraint that is provided by the DRA driver. So
Right.
constraints is another concept that we have in DRA, where the user specifies a constraint and basically
Yeah.
says, I want devices to have the same shared or same attribute value for some attribute. And we've defined one thing, which is the PCI root, where we've said, okay, we as Kubernetes, we define a certain attribute name, and we expect DRA drivers to use that attribute name in a certain way with certain values. And then across drivers, you can basically select devices that are in the same PCI root. But that's user controlled. Users don't need to use that constraint. What you described is basically where the driver says, if you pick this device A from my resource slice or my resource pool, then make sure that any other device that gets allocated alongside it shares, say, for example, an attribute that I've defined as the DRA driver offer. That would be one way, I think, of doing what you are looking for. And we don't have
So,
that. So it basically would be a new KEP.
okay. So this is sort of related to partition. So what do you suggest I put in my use case in the partition document and then
I
start
think
discussing around
I
that?
think it's a separate feature, separate KEP.
Okay. Okay.
Because what you described doesn't need to be. It could also work for completely independent devices that are not partitionable. So you don't need the counter thing that we have in partitionable devices. You could just have device A, B, C,
Mhm.
and they are normal devices, completely separate. No counters that make them mutually exclusive, except that device A and B, say for example, share a certain attribute, And if you pick A, you can pick B, but not C.
Yeah, you could
And-
think of it that way. Yes. Yeah.
Yeah, and that is orthogonal to some sense to partitionable devices. Partitionable devices, they are just a list of devices. They are not described as being part of each other in certain ways, because that would imply defining some kind of topology. Instead, partitionable devices has this concept of counters that get decremented in memory when allocating a partition. And if you have a counter that has a value of 0 or has a capacity of 1, can go down to 0, you can basically think of this as a mutex. You do either partition A decrements by 1, partition B decrements by 1, and then you can only have one partition A or partition B. But that's exclusion. It doesn't say anything about partition C, which doesn't decrement that counter. If it's a device C, not a partition, then there's nothing that says if partition A has been chosen, C is not an option. We don't have that. It is an interesting thought whether you could try to model it with partitionable devices.
Yeah, actually,
it might be worth running through some real use cases and see whether you can define counters in a suitable way to get the desired effect. But I'm not entirely sure, because it just might work. It might not work out. It might be the wrong model, and it might work for some cases, but not all of them. So a good first step would be giving some abstract examples and then trying to model it with partitionable devices. If it doesn't work for some cases, then a new cap might be needed.
okay.
Correct me if I'm wrong, but I understood what Nitish said as distinct devices, not partition of devices.
Yeah. So partitionable devices doesn't really need to be a partitionable device in the strict sense of a MIC device.
Oh, okay.
It's the concept is more general.
Ah,
Yeah.
We've
So,
defined it. Yeah.
sorry. Yeah. No. Sort of. Yeah. That was the reason why I approached this, is because the more I was thinking about this problem, because I looked at the counter sets defined by the SCEP 4815 as sort of course, it's looked at as introducing a shared resource, but I looked at it as, okay, this is defining some sort of a relationship between, at least now in this case, a full GPU and its partitions, but it is trying to define some sort of relationship between these. And so I was thinking of some sort of an extension to that, to say that, okay, right now we have a very simple model of a counter set which can only be consumed additively. So you can only subtract from this value. But why not have a different sort of a counter set, say, that we call it a mutex counter set, or a counter set that can be held by a group of devices or things like that, different behaviors that could model different relationships between devices. That was my thought. So that's why I thought maybe partitionable devices was this one, but I can put in a document and put in my use case, so we can discuss if it's a new cap. Yeah, we can discuss the use case.
We could actually have a counter that starts with capacity 0 and that gets incremented when allocating a device. That would be perhaps one way, but I'm now speculating. So listing the use cases, trying to model, that would be the right step.
I just want to level set for my own understanding. Partitionable devices are for MIG base GPU, right? MIGable.
That was one use case.
Okay.
Yes.
What other use case?
Um,
If you can point me to documentation, that would be great.
Yeah, the first link in that table is the cap issue,
Okay.
and then
I
that
don't have
takes you to.
access to the doc. I request access.
If you join our working group,
Ah.
device management Google group, the discussion group, then
Okay.
you get access.
Okay.
It should have been shared. That's how we do access control in Kubernetes. We have these Google groups, and documents, slides get shared with that Google group.
Okay. Because I know, and Nitish can correct me if I'm wrong, AMD doesn't have MIG concept in their GPU, right?
We have a concept of partitions, GPU partitions in AMD too. Yeah, and in that way, this KEP 4815 does help, but also there are certain additional constraints that partitions introduce in a node among the other GPUs. So we would need to sort of model that. Yeah, it's not exactly like MIG, but we do have partitions too. Yeah.
Oh, okay. And does that apply to Versal also?
Sorry, what was that?
The AMD Versal? VERSAL?
I'm not sure. Yeah, this is mostly for the MI series.
MI series.
Yeah,
Okay.
accelerator. Yeah.
Okay, thank you.
Okay, I think I was going through, I got down to resource-less data. So this is now getting to a point where, say, for example, device binding conditions, we would need to discuss with the CAP owners whether they are okay with delaying the beta by another cycle. They introduced binding conditions in 134, but because it's a new feature and there is one pending change request, perhaps even that would imply some API changes, it just might not be ready. And it's another question of reviewers, whether they have time to review, whether changes need to be made and whether they need to be reviewed. We haven't finally decided. So it's still listed as beta, but we need to make a decision. And the decision in Kubernetes for this release needs to happen within, I think, the next 2 weeks, because as you might know, the CAP process basically states that at some point, first step is now coming up on October 9th, the production readiness review. The CAP update that is suggesting promoting to beta must be complete. It must have certain sections filled out. And then the production readiness team reviews that section. And 1 week later, 1.5 weeks from now, I think it falls on a Friday. All CAPs that plan to graduate or change a feature in 135 must be updated and reviewed and merged. Same consumable capacity is in the same boat. It actually had some bugs in alpha in 134, so there wasn't really an opportunity to try it out, not completely. So it might have to be downgraded as a target to alpha and to do another round, which is actually the usual thing. Promoting from alpha to beta directly in the next release is very aggressive. And we've had so many new things that I think we need to slow down a bit. And then we have reserved for workloads. That's the concept for handling larger sets of pods that share a claim. Right now, the DRA API explicitly lists all consuming pods in the resource claim status. That makes it easy to track whether the resource claim is in use, because every single consumer must be listed in that one place. But it has size limits, scalability limits. I think we are up to 128 pods which can share a claim. And then there are use cases that ask for more. And that CAP is an attempt to handle that, but it's not easy. We still haven't finalized the design. Okay, prioritized alternatives. Probably just staying in beta because there's no urgent need to to promote it. And then some more caps where we just really have an idea and we need to think about whether it's feasible, whether what design looks like. And I just see that Morten for the resource slice mixin already said that he's not working on that for 135. So that gets pushed out again, one release. Yeah, that's where we are. Overall, I can share that we are constrained by now mostly SIG scheduling. We used to be routing DRA changes through SIG node, but most of these changes really affect the scheduling side of it. So a lot of these things need to be reviewed, approved by SIG scheduling people, and they also have other work going on. The group scheduling, gang scheduling thing is something that they want to work on, and we just have to be aware that even if we as contributors want to do something, reviewers might not be able to pay enough attention and spend enough time on reviewing caps, reviewing implementation, that we have to prioritize.
Yeah, that's correct, Patrick. We want to. We spend a lot of time and put a lot of focus on the gang scheduling and more wider effort, like workload aware scheduling. But yeah, we will try to our best to perform the reviews. Most of them are not new things, so that's a good. We don't have to like understand everything. So hopefully there will be no many issues.
Yeah. So for those who don't know, Dominic, he is SIG release approver and reviewer. Are you tech? I think are you a tech lead or chair?
Yeah,
I don't always remember.
I'm a technical.
Yeah. So tech lead basically means that he's doing the technical work, and some other people, the chairs, are running the SIG, making sure that meetings happen, deadlines are met, and so on. Sometimes people do both at the same time, but we try to get away from that a bit in Kubernetes because it is different skill sets and different expertise. Yeah. Okay. That's what I had. Let me see whether anyone added something. No other topics for today. We can make it a shorter meeting if people don't have anything else to discuss. I know it's late for our US colleagues, folks, so don't want to keep you up too long.
I also haven't followed on the discussions that we had previously because we had additionally a few problems in scheduling. So we were investigating the possible degradation, and yeah, that was the urgent thing we were looking at.
So something that we did with DRA, or could
no, that was related to asynchronous preemption. This is what we identified, but we are still investigating a few other features that we implemented, how they impact the performance, especially if the API server is slow to respond.
Okay. Yeah, that's a risk with doing all of these things very quickly, that there's really just not enough time for stabilization, thoroughly investigating the impact. That's why we may have to slow down a bit.
That's correct.
Yeah. Okay. Well, thanks for the feedback. We know where we are, I think, now. It seems doable to me, but as usual, reviews will be tricky. I know that I get pulled into quite a few things, and I've been pushing back myself quite a bit in this cycle, where I'm saying that I won't be deeply involved, for example, with the extended resource API. There is an ongoing meeting that I'm not joining personally, just because I want to have time for the other things. But sooner or later, these things still get to me when it comes for approvals. But yeah, I hope I can manage those.
Yeah.
Okay. Last call. If there's nothing else, then thanks for joining. I look forward for more discussions next time, and see you. Bye.
Thanks.
Thank you.
Thank you.